climate change. I'm going to be talking about organic wastes, how it relates to climate change. More specifically, what are some of the global impacts from that, and what are local solutions that you and I can employ in our neighborhoods and our communities to help address some of these issues. So as Anna said, my name is Jesse Kerns. I got a master's degree in environmental science from the SUNY College of Environmental Science and Forestry, ESF. It's right here in Syracuse. The campus is adjacent to Syracuse University. And I work at the Syracuse Center of Excellence. It's this really cool, funky building in Syracuse. It's right where Route 81 and 690 meet. If you've ever been driving through there, you might have seen this building that looks kind of like a ship. That's my office. That's where I work. I'm right here on the second floor. And I'm a program coordinator for the Syracuse University Center for Sustainable Community Solutions. As Anna kind of said earlier on, this department, I don't do any teaching at the university. I don't do anything on the facility side of things. My office is funded through federal grants. So from the United States Department of Agriculture, from the United States Environmental Protection Agency. We have a couple of New York State grants too. And so I go out into communities and I work with various stakeholders all across New York State to help them with a topic called sustainable materials management. So I'm focused mainly on what are the wastes that our society produces, and then what do we do with those? How do we manage those? And trying to mitigate, trying to prevent a lot of negative things from happening through the mismanagement of those materials. So what are the traditional ways that we deal with materials when we're done with them? We talk about this as a linear economy. So we go out into the environment, we extract resources like trees or minerals from the ground. We convert those into products. Those are sold in stores. We use those for our benefit. And then when they break or they wear out or they just get obsolete, then we get rid of them. We throw them in the trash. But where's away? Where do these materials go? And there's a couple of main places that we send these to. Number one is a landfill. And this is a landfill out near Albany, New York, the state's capital. And this is what it looks like. You've got these large trucks full of our trash driving up onto this mountain, more or less. They dump all that material out, and then you've got these other big machineries that squish everything down, trying to save as much airspace as possible. And this is everything that you can think of. It's known as municipal solid waste. So anything that you put in your trash can, it goes to a place like this. Notice in the background, there's some houses back there. I don't know about you, but I don't know if I'd want to be located so close to these landfills. And it was interesting, Anna, to hear that you are interested in and work on social justice issues too, because this is something that's known as environmental justice. Some of these facilities historically have been placed near communities that are facing economic hardship, that are tend to be low income communities of color that don't have a lot of political ability to fight back against where these are sited. And it's known as environmental justice. So I just wanted to draw your attention to that. Another main way that we deal with waste materials is through incineration. And this is a facility that is owned and operated by a company called Covanta. And it's right in the Syracuse area, just south of the Syracuse campus. You might have seen it if you, instead of going through the city on 81, if you take 481 around the city, you'll drive right by this facility. Notice the big smokestack here. Once the trash is burned, it has to go through a series of devices that help to take out a lot of pollutants. Those devices are known as scrubbers. So this is the traditional way that we deal with materials, and there's a lot of issues with it. Here's a photo too from the inside of an incineration facility. This is what it looks like. It's like an arcade game with a big claw where it grabs all the trash and then it puts it into a big combustion chamber and burns it all up. So instead of the linear method, the take, make, and waste method, I'm focused on trying to integrate and rework the waste management system into something known as sustainable materials management. That's the term that was coined by the Environmental Protection Agency. You might know this better as the 3 R's, as reduction, reuse, and recycling. So reduction, looking at all the goods that we use to better our lives, and what are those that tend to be single use that maybe we could opt out for reusable options. So here I've got a lot of things that maybe you've experienced single use, plastic water bottle, maybe plastic to-go containers, maybe a plastic straw. And this is just an array of an example of different products that you could swap for those that you can use over and over again and prevent waste before it even occurs. The other R, reuse. I love this photo. It's a beautiful photo of a hardwood floor, and these planks were taken from various sources, so old farm barns, and they were reprocessed, so they were sanded and planed off and then stained and then maybe put some sort of finishing coat on them and repurposed for a very, what I think is a beautiful and functional option for home renovations. And then the last one, recycling, which I think we're all pretty familiar with. These are a lot of the packaging materials that you get. So milk jugs, anything that food packaging kind of comes into, we tend to have a lot of those materials on a weekly basis. And they go to a facility like this. This is known as a MRF, an MRF, that's Material Recovery Facility. So a lot of communities throughout New York State now are accepting recyclables in one bin. Everything is commingled. But they can't be sold that way because there's so many different materials. There's plastics, there's glass, there's metals, there's papers, and they have to be separated again before they can be sold and turned into new products. Here comes my cat. She might Zoom bomb us. I just heard the door squeak. So if she jumps up, her name is Willow. So yeah, this is the recycling process. Here she is. Everyone say hi to Willow. This happens in all my professional meetings too, and I think it's quite funny. All right, so sustainable materials management is a lot more than just the 3 R's. It's more than what we do with the materials. It's how we think about waste materials, because ultimately how we manage waste materials springs from the way that we think about them. And traditionally, we think about the materials that we're getting rid of as valueless, as we have so many words for it: garbage, trash, waste, rubbish, refuse, junk. You know, we call these things all sorts of stuff. And I really want to challenge you to look at waste materials with a different eye after the presentation today. I want you to start thinking about them differently and start to try to think, what is it about these materials that's still valuable, even though we're putting them into the trash? So for an example, this was my cell phone when I was an undergraduate in college. And maybe you're all going to laugh at me. This is not a smartphone. This was one of the best phones you could get before smartphones came onto the scene. It's a Verizon chocolate. I loved this phone. I could text with it. I could make phone calls. That was pretty much it. I think it had a calculator, maybe one game, the snake game that you could play. Anyways, I use this as an example because I don't think I could pay any of you on the call today to take this, because what's the point? You have phones that are so much better. So functionally, it's valueless. It doesn't have any functional value because it's obsolete. We have so many other devices that are much more better than this. But does that mean that it's completely valueless? And I would say no, because there's some material value to it. If you were to crack open this plastic casing, you would find the circuitry of this electronic, and in the circuitry are some very precious metals. There's silver, there's gold, there's platinum, there's palladium, and these took a lot of effort to extract from the environment, and they're precious metals. They have a lot of value. So should we be throwing that phone into the trash? I would say no. We have to figure out some way to deconstruct this phone and to extract those metals and to put them back into beneficial use again. So that, in a nutshell, is sustainable materials management. I want you to start challenging yourself to not say waste or not say trash, but to say materials, and maybe they have some sort of value. So Anna, she's got a banana peel on her shoulder. Let's use this. This is another example of mine. That banana peel to us doesn't have any value from a food standpoint, because we just wanted the middle of that banana. We didn't buy the banana to eat the peel. But that doesn't mean it's waste or that it's valueless. There are some valuable nutrients in that peel that are valuable to plants, maybe plants that we want to grow in our gardens as food, and we can reuse that through a process called composting that I'll talk about in just a little bit. I got to keep an eye on the time here. It looks like I got about a half an hour, so I'm going to keep cruising. I think Willow took off now, so we can make up for time. There's a lot of different wastes when you're talking about sustainable materials management and municipal solid waste and waste management. Today, I'm going to focus specifically on those materials called organics. And when I say the word organic, I'm not talking about the USDA certification, the growing practice organic. I'm talking about those materials that are derived from anything that was once living. And the photo in the background is just a good example of all of that. So anything that's food related, anything that ends up in your yard, like leaves or grass or twigs, even things that you might be wearing, so cotton or wool clothing, and then paper too, because that comes from trees, woody biomass. So we're focusing on organics today. So let's talk about the problem, the ways in which organic materials are mismanaged through our waste management systems and how that contributes to global climate change. This is a photo from Cornell University. They have a large composting facility down there, and this is all the food waste that came one day from their dining halls. You can see a bunch of stuff in there. It looks like a little ham. There's the watermelon, pineapples. There's a lot of stuff in there. And I put this up to demonstrate to you this statistic that I find absolutely astounding, that 30 to 40% of the food that we produce in the US doesn't actually get eaten. 30 to 40%, that's a third to almost a half of what we grow in the US doesn't go to nourish somebody. It ends up as waste somehow. And this waste issue was an issue before the pandemic, but it's been made even more of an issue because of the global pandemic. This is just an example of a headline from an article from the New York Times back in April that reads, "Dumped milk, smashed eggs, plowed vegetables, food waste of the pandemic." So what happened, as you remember, all the restaurants shut down, and a lot of farms and distribution companies relied on those restaurants as a place to sell a lot of their produce. And so when they instantaneously shut down, those farms and those distribution companies had nowhere to send their materials, their food that they had grown. So a lot of it ended up going to waste before it could be sold or rerouted to other individuals. It was a huge issue and still something that we're trying to shake out even to this day. There have been some really great efforts through the state. So the state has been providing funding to area food banks so that they can go out to local farmers and say, what do you have a lot of extra of? We'll pay you with state funds to get that material so we can then donate it back out to those families in need right now. Food waste, 30 to 40% of all we grow. What does that look like on the big scale of things? If we were to put all those farms worth of food waste together, it would be roughly 80 million acres. So we need 80 million acres of the US to grow food that does not get eaten. That's big. That is really geographically big. I'm going to use this slide to show you that, so food waste doesn't happen in just one spot. It happens at every step of the food chain, the food production chain. So there's a little bit of food waste on the farm, a little bit of food gets wasted in the trucking to wherever it's going to be distributed. There's a little bit of food waste in the grocery store. There's a little bit of food waste at home, at restaurants, in schools. It happens everywhere, and it adds up to this big number. And maybe that's why it's kind of hard to see for us in our day-to-day lives, because at home we're like, oh yeah, maybe we're wasting just a little bit of food. Then at school, oh yeah, maybe we're wasting a little bit of food here too. But when you add it all together, it's this big sum, 30 to 40%. Though I do want to say that the biggest portion of food waste is attributable to residents. So if you just look at homes all across the US, that's where roughly 40% of all this waste is happening. But as I just mentioned, it's also happening in schools too. The Minnesota Pollution Control Agency in 2010, they did some studies with schools throughout Minnesota, and they found that by digging through the garbage cans in cafeterias and actually looking at the garbage from the rest of the school too, that roughly 50% of what K through 12 schools are throwing away are organic materials. Some of that is food, but also some of it is paper towels, some of it is paper. So roughly half of what schools are getting rid of can technically be composted, and I'll get to that a little bit later too. I do want to mention that there's a lot of facets, a lot of factors, a lot of stakeholders in the work that I do. But for today's presentation, I've tried to root them into things that we can see and do at schools and things that we can see and do at home too. So what's this look like from an economic standpoint? Since public schools are funded through taxes, we want to make sure that we're using those tax dollars responsibly. Nationally, schools waste $5 million in food every day. And that's $1.2 billion per year on a national level. $5 million every year, that's crazy. And that sounds like a huge sum, but when you consider there's roughly 100,000 public schools throughout the US, that's roughly $50 worth of food per school per day. So it's definitely a realistic number, but when you look at it on the national scale, it's pretty staggering. Any questions so far? Okay. I think I'm just scaring everybody. I'm just putting out all these scary stats. Okay. So let's look outside of the school. Let's look at municipal solid waste. So those waste materials that come from homes, that come from businesses, that come from schools. If you were to go to a landfill and take a truck, this is called a waste characterization, take a truck, pull it off to the side, and then dig through all the bags and sort everything out into different classes of materials, which is somebody's job. People actually do this to keep track of what's happening. If you were to do that, separate everything out, you would see that roughly 15.2% of all the things that we're throwing away is food. So that's another way to look at it too. We're wasting 30 to 40% of what we're growing, and then the total waste stream of what's going to landfills and incineration, roughly 15% of that is food. That's a lot. That's a big category. I wanted to back up too. So this landfill that you can see in the background is north of Oneida Herkimer. It's managed by the Oneida Herkimer Solid Waste Authority. It's in Boonville, New York, and this is what their landfill looks like. Pretty similar to the one in Albany, right? This is that same landfill in Boonville, New York, but it's got these devices on it. So what happens when we take food and other organic materials and put them into a landfill? How does this relate to climate change? And the answer is that, remember those big trucks that I showed earlier too, that was crushing all the material, squishing it down? It's also forcing all of the oxygen out of there. And what happens is when organic materials break down in a landfill, in an environment that's known as anaerobic, so no oxygen, it produces methane gas. And these devices here, this is known as a gas capture system. I think this one actually in Boonville was paid for by Google, you know, the company Google, where you search all the stuff online. They have these environmental goals that they want to reach, and so they provide some grant funding to waste management and other areas in the energy sector all over the place. But I thought it was pretty funny that this landfill in upstate New York was paid for by Google, or the gas capture system. So anyways, this system is meant to capture a lot of that methane, and then they burn it off. So they flare it on site. Some of them are more sophisticated, and they can create some energy for if there's a little outbuilding or other types of operations on site that the Waste Management Authority needs. This methane gas can be used to produce energy. So what do I got here? Got to keep moving these windows with all your faces over so I can see what I've written. So if you were to look at all the landfills in the US, you would see that the methane that's being produced by them is 14% of all the methane emissions that we produce in the US, and that's a stat from the Environmental Protection Agency. So how does it produce methane? I said that it happens in an anaerobic environment, but what's really going on there? There are these microorganisms that are known as archaea. So they're not bacterium. They're a different class. They're known as archaea. And when they break down organic materials, they go through respiration just like you and I do. So when we're out exercising, we're breathing in oxygen and we're creating energy with our bodies. What we're exhaling is carbon dioxide. So archaea do the same thing. It's just when they more or less exhale, they're exhaling methane through their respiration. And this is a process known as methanogenesis. Methane gas, as you probably know, is a very potent greenhouse gas, just like carbon dioxide. It's estimated to be, if you look through the scientific literature, studies that are being done on it today, it's estimated anywhere between 25 and 34%, 25 to 34 times more potent than carbon dioxide. So it has 25 to 34 times more heat holding capacity than carbon dioxide does. So it's going to warm up the planet much quicker than carbon dioxide was. I'll throw in the caveat that methane isn't as long lived in the atmosphere as carbon dioxide is, but in the short term, it holds in much more heat than CO2 does. And it's not just the end of life management of organic materials that contribute to climate change. So we send organics to landfills that's producing methane, but there's a lot more that's happening along the way too. So on the farm, when we're growing food and we're tilling the land, that's releasing carbon dioxide. The machinery that we're using, that we're burning diesel fuel in, that's producing carbon dioxide as well. Then once the food is grown, we put it into refrigerated trucks and we ship it all the way across the country and sometimes internationally too. So a lot of our food here in New York was grown in California and shipped all the way across the country. That shipping produces carbon dioxide. Wanted to put up the stat here from the US Energy Information Administration that, just to put it into context a little bit, when you combust 1 gallon of gasoline, that produces 20 pounds of carbon dioxide. Then once the food gets to a distribution center, like your local grocery store, there's some more climate implications as well. So this food has to be refrigerated and kept fresh so that it's still looking good and it's still nice and edible for us when we're at the grocery store. So there's a lot of refrigeration that goes into that, and that's very energy intensive. So the ways that we're producing energy are contributing to climate change as well, and it's tied in very closely with this food production chain. This is a picture of northern China. And so if you were to look at food waste all across the world, so we waste 30 to 40% of our food in the US. That's not unique. This happens all across the world in countries all across the world. I think the national statistic is more like 33%, or I'm sorry, the international, the global statistic is more like a third. But if you were to take all of that CO2 equivalency from food waste all over the world, it would rank third as the largest greenhouse gas emitter, just below China and the US. So if wasted food globally was a country, it would rank third as the most contributions to greenhouse gases. That's pretty big.
Can I ask you a question about that?
Sure.
Put it in perspective. Third, when I think third, okay, I'm like, okay, well, hey, we're a big country. But I guess we're not as populous as, we don't have as many people, right, as China. So is that why it's so shocking? I don't know. I guess I'm saying, yeah, of course we produce more than like France. I mean, we're so much bigger. Does that make
Right.
sense?
I think part of it is our, I think part of it is, that we have 325 million people in the country. So I think population is part of it, but I think our lifestyle is also part of it too. We have big refrigerators compared to European Union households.
Yeah.
We have very large cars. Our houses, everything in the U.S. is kind of supersized. So I think that also kind of contributes to this as well.
Yeah.
So yeah.
Okay, thank you.
Yep. I think really the big thing to keep in mind here is that food waste globally ranks right up there as the contributors to climate change.
And the kind of cool thing is we can do something about it.
Yeah, exactly. And I'm hoping to get there too before we run out of time. This goes until only 2:15.
I can check again.
Okay.
I'll double check.
Sure. I gotta keep moving. So anyways, there's a nonprofit organization known as Project Drawdown, and they label reducing wasted food as one of the most impactful things that we can do to reduce and to prevent climate change. So Project Drawdown, they're working to get to that point. They want to stop the rising CO2 in the atmosphere, and they want to start to bring it down. They want to start to draw it down. So that's where that name comes from. This wasted food issue, we're wasting so much, 30 to 40%. It's even more egregious because in New York State and across the country, roughly 1 in 8 of our neighbors are facing food insecurity. So they're facing poverty is the root cause, but they're also facing food insecurity, which means that they either don't have the economic means to readily get fresh produce for themselves, or they live in an area known as a food desert where they don't have easy access to the type of nutritious food too. There's a lot of historical factors that go into that, a lot of environmental factors, and a lot of social justice and racial justice factors that are resulting in that. And people in my field will say, well, if we could just redirect some of that surplus produce that's being wasted and use it to feed those that are facing food insecurity, isn't that solving two issues in one go? And yes, that's a good short-term solution, but we need to look at the root causes of these issues as well. Why are we wasting so much food in the first place? And then why are 1 in 8 of our New York neighbors facing poverty and food insecurity? We need to address those root causes so that we can have much better, much more impactful solutions in the long run too. So solution number 1 to this wasted food issue, what do? We reduce the amount of wasted food. I'm going to bring you back to the school level. So to understand how much food is being wasted in the school, we can do what's known as a waste characterization. We can do a cafeteria waste audit. And here's some students doing just that. And so you do that to number 1, see what types of food are being wasted, and then also to see how much food is being wasted. Because then afterwards, when you're introducing other interventions to try to reduce food, you have a baseline that you can set that against. Also, these are handy too because they can point to certain foods that are being wasted that could then be brought back to your food services department. So maybe for some reason we noticed that through this waste characterization that all the food that's being wasted are grapes. And you would say to yourself, why are the grapes being wasted? Let's go back to food services and see if there's an issue there. For some reason, they're just not being eaten. So these are very handy. EPA has great guidance that we can share with students to show them how they can do this in their schools. Another option is to employ what's known as offer versus serve. And this is a provision allowed by the US Department of Agriculture. So instead of just handing students plates of food and saying, here you go, this is what you get today, have some options so that, they need to take a certain number of different food groups in order to fulfill what's a reimbursable meal. But by having a little bit of options, we all appreciate options, right? We don't want to just be given one option and say, this is all you get. That's going to reduce some wasted food significantly. Recess, I think this is a cool one, especially in like K through 5 schools. If you schedule a recess before lunch, the U.S. Department of Agriculture has found that we can reduce plate waste by up to 30%. And then also lunch periods. This was a huge issue for me in high school. I know I hardly ever had time to eat. By the time I'd get through the line and get my lunch, I'd have 3 minutes to wolf my food down. So once again, the U.S. Department of Agriculture found that if a school is able to extend their lunch periods from 20 minutes to 30 minutes, just adding an extra 10 minutes, we can reduce plate waste again by another 1/3. This is a really cool strategy known as a sharing table. So this is an option that is allowed by the the New York State Department of Health and also the New York Education Department. They've come together and created guidance for this. A sharing table is a little refrigerated table right at the end of the service line. So if a student walks out and they say, you know what, I'm not going to eat this yogurt after all, they can put it on the table, go and have a seat, and then other students in the cafeteria who want a little bit more after they've eaten can go up and take that free of charge. It's a little legal gray area because in New York, you're technically served when you sit down at your table. So you're still in that transition zone and it's allowed. Sharing tables, very cool. What about the home? What are some things we can do at home to prevent wasted food? Number one, commit to eating leftovers and highly perishable foods too. If you're one of those people that are like, nah, you know what, leftovers, they're not for me, then that just comes back to your meal planning a little bit. Maybe you only make enough for dinner so that you eat everything that's made and there isn't anything left over. But that's a big one. Number two, being organized. So creating a meal plan, knowing what you're going to have for breakfast, lunch, and dinner, either for a couple of days or like I do on Sundays, I make a meal plan for the entire week. So that when I go to the grocery store, I know, okay, I'm cooking dinner, breakfast, lunch, and dinner for 2 people. Here's what we're going to make. And I know exactly the amount of materials that I need to buy so I don't have random leftovers of things. It takes a little bit of commitment, but it's something that and it sounds pretty straightforward too. It's pretty obvious, but it can be, it's not the most fun things week to week, especially when you have a brain block and you're not sure what you want to eat on Friday when it's Sunday afternoon. Anywho, this can save a lot of wasted food. Being organized, I found this crazy photo on the internet. This is not my fridge, but it goes to show you that if you are organized, you can see what you have and you're not losing track of things. I'm sure we've all had the experience where you're digging through the fridge and then in the back corner, you found something that has been forgotten and is growing all kinds of mold and you can't even tell what it was to begin with. Yeah, so being organized can help us to prevent wasted food as well. So it's not just the fridge, but it's also the pantry too. And make sure to check those 2 places, your fridge and your pantry, while you're making your grocery list so that you don't accidentally buy something that you already have. There's a lot of techniques for perishable produce storage, and I've been experimenting with a lot of them the last couple of years. Celery, you might read online, put celery in a glass of water and it'll stay fresh for a week. Every time I do that, it goes floppy after 3 days. What I found works the best is aluminum foil. For some reason, when you wrap celery in aluminum foil, it'll last you 3 weeks and it'll still be nice and crisp and firm. I don't know the science behind it. I've seen it in a couple of places, but that works the best is what I found. Same thing with fresh herbs. You snip off the bottoms like fresh flowers, put them in a glass of water, put a little baggie over top and put them in your fridge. They'll last up to 3 weeks as well. So learning all those cool, handy techniques to give your produce life until you get a chance to eat them. You can check out some preservation options, so canning, pickling, freezing, dehydrating. What are things that we can do to perishable food to really extend their shelf life? And these are just some options. This is a cool thing that I like to do with my wife as well. So learn nose to tail and root to leaf cooking techniques. That just means try to utilize all parts of the things that we're buying and finding edible options for them if it's possible. So one thing that we do is we save our our carrot peels and our onion peels and the little shucks from our garlic, the stems from fresh herbs. We save those in a freezer container, and when we have a full container, we put it into a pot of water, we boil it for a couple of hours, and we have really delicious homemade vegetable stock. Okay, so that's the prevention. Sorry, I'm really flying now because this session has just been going by so fast. We've got about 8 minutes. So really quickly, I'm going to go through solution number 2, which is recycling organic materials, which is also known as composting. We've mentioned this a couple of times in this presentation so far. So what is composting? It's a picture of a log that's rotting, decomposing in the forest. And that's what composting is. It's more or less natural decomposition that we're harnessing to recycle materials into their base components so that we can use them for beneficial purposes. So it's natural decomposition. It's going to happen anyways, but there's a number of parameters that we can control and that we can adjust to speed up this process and to achieve certain outcomes that we want. This is a photo from Seneca Falls Central School District. It's out by the Finger Lakes region of New York State. This is near their parking lot, and this is their on-site school composting setup. So they take all of their food scraps from their cafeterias and they compost them right there at the school. You can see that right bin all the way to the right there. That material is really dark. It's almost done. It's almost complete. So you can't even see any food scraps in there anymore. So how's the process work? It starts with collection. In the cafeteria, you need to separate all of your food scraps from everything else. So if your school has styrofoam trays, if they have plastic utensils, plastic beverage containers, all that stuff cannot go into the compost. You need only those things that are organic, only those things that came from once living things. And so you've got a nice photo here on the sign that they made of chicken nuggets and hamburgers, apple core peels, banana peels, all that kind of stuff can go in. So you see this young student here, she's emptying some materials into the collection container. Then you need your nitrogen-rich green materials. So this is half of your feedstock, those nitrogen-rich materials. And just like that sign showed, it's all those food scraps. It's all the things coming from the cafeteria. So it can be fruit, it can be vegetables, it could be meats and cheeses and milk and whatever that brown stuff is. Oh, is that a cookie? I don't know. It looked not appetizing at first, but now that I know it's a cookie, it does look appetizing actually. So yeah, all that stuff can go in there. Let me put in the caveat. If you're composting at home, you do not want to include cheese and meats and dairy products because the scale at which that just your family is composting is not going to be large enough to properly decompose those materials fast enough or at the high enough temperature. So this is only at the school scale. And it works at the school because you have so many students, so you're producing enough material that you can have the size necessary to achieve those internal temperatures that you'll need. So after the nitrogen-rich green materials, the wet materials, those food scraps, that's not it. You need a carbon source. So you need some very carbon-rich brown materials. And I got coal in the background to signify carbon. So what are those? What are relatively high in the element carbon? Leaves, landscape debris, wood chips are a good source too, and those are pretty necessary for on-site school composting because they help to keep everything lifted up, which will be important in a second. Paper towels, non-bleached paper towels. If you have bleached paper towels, there's a chance that some of that trace bleach substance can come into your compost and cause some issues later. So you're looking for unbleached paper products when you're introducing those. How does it all work? So we talked about the two major food sources, the greens and the browns. And here's how it goes. First, you collect all your materials from the cafeteria, those greens, and you put them in. You lay them out into a layer. And then next, you want to add in your brown materials in a 3-to-1 ratio too. So for every 1 bucket of food scraps you're putting in, you're going to want 3 buckets of brown materials. That's the right recipe for composting. Add the browns. This is another on-site school composting system. And you can see here, instead of using their environmental club or their sustainability team to turn the materials, they've got this nice machine that's doing it for them very quickly too. I put this in here because the third ingredient, so greens, browns, the third one is oxygen. You're seeing that this is starting to kind of mimic what you and I need, right? We need food. We need the right balanced diet of food. We need some oxygen. And we also need some water too. So that's the fourth ingredient, is water. And I put if needed here because food items have a lot of water in them, in the cell walls that they'll release as they start to break down. And then if your bin is uncovered too, you're going to get some rain in there as well. So it's something you have to monitor and add if need be. All right, I got 4 minutes. We're doing good. We're cruising through. So once you get it all together, once you get it mixed in there, and you've mixed in some oxygen, because remember, we don't want this to be anaerobic like the landfill. We don't want those archaea producing methane. We want to introduce oxygen, which will help us to propagate those microorganisms that are going to use oxygen for respiration and help break things down. That's why oxygen is important. But once they do that, once they get to work and they're breaking things down, your compost pile is going to heat up. And here's one on a farm that's steaming. And these compost piles at schools, are in the least 5 feet squared. So 5 feet by 5 feet by 5 feet. And internally, they have these compost thermometers. If you were to probe them with these thermometers, as this pile becomes active, you'll see that the temperature will climb upwards to 150 degrees Fahrenheit, sometimes even 160 degrees Fahrenheit if you're really actively managing it. And that's all due to that microbial respiration. So those microorganisms that are munching all of those food and other organics, they're the ones producing all of this heat. And moving the process forward too. So 160 degrees Fahrenheit, think about that. That's practically to the temperature that we cook pork to. Pork is, I think, 165 technically, but very close. So does composting just happen? Does it just magically happen? Is it us that's composting? No, it's all of these decomposers, all of these compost heroes, and there is a whole host of them. There's really fascinating food webs of decomposers in our compost piles. And here's just a few. So you've got Eurasian earthworms, you've got pill bugs, you've got microscopic organisms like these nematodes, springtails, rotifers, all the things that are really fun to look at under a microscope. You've got fungi. This is mycelium from fungi. So those root-like, thread-like structures that come out from the fruiting bodies, or it's actually the main body of the fungus itself. Mushroom is just the little fruiting spore body of a fungus. They do a lot of decomposition. Bacteria too. This is a great photo from, it's an electron microscope photo of soil, and you can see some of the bacterium here on the left-hand side, these little pill-shaped creatures. So they're the ones actually doing it. How long does composting take? It can take a number of months, depending on how actively you're managing it, what the size is, what feedstocks you're using. So anywhere between 6 and 12 months, you'll go from a banana peel down to finished compost. And you can tell it's working because those food scraps will start to disappear. They'll become less recognizable as food. And in the end, this is a photo of my backyard compost that I made myself. You won't be able to recognize leaves or food scraps at all. It'll turn into this end finished product. And compost is defined as a nutrient-rich soil amendment. So it's not mineral soil, it's a nutrient-rich, it's mainly organic material and nutrients. It'll cool down, so it won't be so hot anymore. It'll look dark and crumbly. It'll have a sweet, earthy smell to it. And it has a lot of benefits when we add it to the soil. So if you have really sandy soil, it improves its physical structure by holding water and not letting it just run through the water column. And the same thing for clay too. It'll kind of break up those clay-like structures so that water can sift out a little quicker and not just sit there in the roots of plants. It increases the biological diversity and activity of soil, which soil isn't just dead, it has a bunch of life to it, and plants rely on that life in order to grow well. And it also introduces a lot of nutrients and organic matter that plants need to be very healthy too. So bring it all back for climate change. If we were to introduce compost with our agriculture and also with cover crops, this is a photo at UC Davis in California. It's known as the Century Project. So they're looking at agricultural practices over a 100-year period. And they found that if we apply compost with cover crops, that we can start to sequester carbon in the lower parts of the soil column and take it out of the atmosphere, so it helps to mitigate climate change a little bit. It's really fascinating findings that they have there through that study. At school, we can apply compost to our athletic fields, so we can get away from some synthetic fertilizers, because that compost will add nutrients for our turf grass and other landscaping that we have at school. And then finally, maybe your school will be interested in having a little demonstration vegetable garden too that you can put your compost into as well. Sorry, I flew through all of that. So here's my contact information. If you want articles or videos or other resources, feel free to email me there. Or if you have questions about this presentation, I'd love to answer those for you. So once again, thank you so much for your